Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to arithmetic progression. So far we have discussed various questions related to general nth term of an AP, but all of these questions, they were related to the general nth term from the beginning, from the first term. So here we'll discuss another concept, which is the general nth term of an arithmetic progression from the end. Okay, this. So let us see what I'm trying to say. So let us say we have an arithmetic progression. Okay, so here we have an arithmetic progression, which is the first term is a, the second term a plus d with common difference small d, the second term, this is the third term, is a plus 2d, the fourth term is a plus 3d, and so on it goes. Now if we write the same arithmetic progression, let's say from the end, from the last, this is from the first, from the beginning. Okay, if we try to write the same thing from the end, it will be, let's say, the last term of this arithmetic progression be L, small l. Okay, this is the last term of the arithmetic progression. The term just before it, it will be less than it by the common difference, so it will be L minus d. The term before it, it will be less than this term by d, so it will be L minus 2d. The term before it, that is before L minus 2d, it will be less by a factor d, so it is L minus 3d. Okay, like this. So this is from the beginning, the first term. This is from the last, from the end. This is the last term of the arithmetic progression. And here the same thing, common difference of small d is maintained throughout. Okay, common difference of small d is maintained throughout. So here the general nth term, okay, the general nth term from the beginning is given by a plus n minus 1 d. This is from the beginning, from the first term. Similarly, from the last term, the general nth term, we will write it as L subscript n, that is the nth term from the last, from the end. It will be equal to, from here, this is the last term, the first last term from the end, it is L. This is the second last term, okay, the first last term, that is equal to L. The second last term is equal to L minus d. We can write it as L minus 2 minus 1 d. Okay, similarly this is the third last term. Okay, this is the last term from the end, L1, this is L2, this is L3, this is L4 and so on. L3 is how much? L minus 2D, or we can write it as L minus 3 minus 1 D. Similarly, L4 is equal to L minus 3D, which is equal to L minus 4 minus 1 D. So here if you see, there is a relationship between the particular term from the last and here. L1 is L, or we can write it as L minus 1 minus 1 D, which is equal to 0 D. L2 is L minus D, which is equal to L minus 2 minus 1 D. Here 2, here 2, here 1, here 1. Here it is 3, L3, which is L minus 2D, which is equal to L minus 3 minus 1D. Similarly, L4 is equal to L minus 3D, which is equal to L minus 4 minus 1D. So the general nth term from the last, from the end, it will be equal to, we can write it as L minus n minus 1 D. This is the general nth term of an arithmetic progression from the end, from the last. This is from the beginning this is from beginning, this is from the end, from the last. Okay, the nth term from the beginning, from the first, this is the nth term from last. Okay, so now we'll be solving some questions related to this. So here is the first question on the general nth term of AP from the end, from the last. So here it is given, find the 8th term from the end for the given AP 7, 10, 13 up to the last term, which is 184, and the total term or the total number of terms that are present in the given arithmetic progression. So here we have to write the arithmetic progression, which is 7, 10, 13, 184. Okay, so now here the first term is 7. The common difference is 10 minus 7, which is equal to 3, or 13 minus 10, that is equal to 3. The common difference is 3. And the last term L is equal to 184. So here it has been asked to find the 8th term, okay, the 8th term from the end, from the last. So we have derived the formula for the general nth term from the end, from the last, which is equal to L, which is the last term, minus the particular nth term from the end, which we have to determine, minus 1 D, which is the common difference. So here we have to find the 8th last term, the 8th term from the end. So it will be equal to L minus 8 minus 1 T is equal to L minus 7 T. So here we'll put the value. The last term is equal to 184. The common difference is equal to 3. So it is 184 minus 7 into 3 equal to 184 minus 21, which is equal to how much? 163. This is the 8th term from the last. and it has also been asked to find the total number of terms that are present. So here we'll take the last term, okay, L. So we know for the last term, which is the last term of the, if you want to find out the total number of terms which are present, we will write it as A plus n minus 1 d. Here deliberately we have chosen the last term, because if we pick the last term and substituted it with this equation, the particular n value will give us the total number of terms that are present. So here 184 is equal to A, which is equal to 7, the first term, plus n minus 1 into the common difference, which is equal to 3. We have to find n here. So that implies three into n minus 1 is equal to 184 minus 7. That implies 3 to n minus 1 is equal to 177. That implies n minus 1 is equal to 177 by 3. So here it will be 9. Okay, so that implies n minus 1 is equal to 59. That implies n is equal to 59 plus 1 plus n is equal to 60. So there are a total of 60 number of terms which are present in the given arithmetic progression. Okay, so this is the thing. So deliberately we have chosen the last term and we use the general nth term of the AP from the first, okay, from the beginning. We have used that equation, the general nth term from the beginning, and we just put the value and got the result, that is n is equal to 60. Okay, so here is the solution, n is equal to 60, using the general nth term from the beginning, and we have put the last term in this equation.